There may be life on Proxima Centauri B. Proxima B is an exoplanet very similar in size, located within the habitable zone of the star Proxima Centauri, the closest star to Earth after the Sun. Astronomers have recently discovered that it has very favorable conditions to host life. Could there be life on this exoplanet? Let's get started. Let's start our journey to the Alpha Centauri star system. This group of 3 stars orbit each other. The largest is Alpha Centauri A, a star somewhat more luminous, big, and older than the Sun. It's classified as a yellow dwarf. From the orbital parameters determined by astronomers, Alpha Centauri A has 10% more mass than the Sun and a radius approximately 23% larger. Next to Alpha Centauri A, we have its companion Alpha Centauri B, a very similar star but smaller than Alpha Centauri A. Both stars are gravitationally linked and are separated by 23 astronomical units. In astronomical terms, it is a very small distance. Consider that the distance from the Sun to Neptune, the farthest planet in our solar system, is 19 astronomical units. Alpha Centauri A and B could fit within our solar system without problems. Because of how close both stars are, astrophysicists think it is highly likely that the 2 stars were born at the same time and have always been gravitationally bound. Then we have the 3rd star of the Alpha Centauri C system, or better known as Proxima Centauri. This star bears that name because it is the closest to Earth. It's currently 4.25 light years from our solar system and is getting closer and closer to us. It is estimated that in about 27,000 years, Proxima Centauri will only be 3 light years from our solar system. And while it still is a considerable distance for human technology, it is much less than the distance it is currently at. Proxima Centauri orbits Alpha Centauri A and B, is the most distant star in the system, and is currently 13,000 astronomical units away from its 2 stellar companions. Proxima Centauri's orbit around its 2 companion stars is so eccentric that it closely resembles the orbits of comets in our solar system. Even at its closest point, every 500,000 years, Proxima Centauri approaches Alpha Centauri A at a maximum distance of 4,300 astronomical units. Due to the nature of the Alpha Centauri system, astronomers have deduced that it is the most likely that in the remote past, many billions of years ago, the Alpha Centauri system captured Proxima Centauri as it passed close to the system, becoming gravitationally coupled to the system. Next, Centauri. The star Proxima Centauri has some planets orbiting around it, and one of those planets is the one that steals the limelight from everyone, Proxima B. This exoplanet was found using the radial velocity method, where periodic movements of Doppler spectral lines of the host star, Proxima Centauri, indicated that an exoplanet orbited it. These measurements were made using 2 spectrographs, the HARPS at La Silla Observatory and UVES at the Very Large 8-meter telescope. On May 24, 2020, a team from the Institute of Astrophysics of the Canary Islands, IAC, and in which researchers from the Center for Astrobiology, CAB, participated, confirmed the existence of the exoplanet Proxima B. They also discovered that it has 1.17 times the mass of the Earth, and that it is in the habitable zone of its host star. Plus, it orbits Proxima Centauri in just 11.2 days. Because of this, Proxima B is located extremely close to its star, with just 0.05 astronomical units from Proxima Centauri, so you can get an idea of how close this is. Mercury is 0.4 astronomical units from the Sun. Does this mean that Proxima B is a planet with an infernal climate like Mercury or Venus? Surprisingly, it does not seem this is the case, because the star that orbits Proxima B is much smaller than the Sun, that is, Proxima Centauri. Proxima Centauri has about 12% of the Sun's mass and a radius of only 15% of the solar radius. It is tiny and much colder, since its temperature is 2,725 degrees Celsius, which is less than half the Sun's temperature. Because of this, Proxima B receives only 60% of the energy that the Earth receives from the Sun. In addition, the habitable zone of each star changes depending on the size of the star. As Proxima Centauri is much smaller than the Sun, its habitable zone is also closer. So although Proxima is exceptionally close to its star, it is located just within the habitable zone, one of the most important requirements for life, which means that it is highly likely that life can develop on this world. Problems for life. Although Proxima B meets one of the essential requirements for hosting living things, many other requirements that might not be met are still missing. As we mentioned earlier, Proxima B orbits Proxima Centauri in just 11.2 days. Because of this, we can assume with a high degree of certainty that the axis of rotation of this exoplanet will be perpendicular to the plane of its orbit, so there will be no stations, and that it will most likely present a synchronous rotation, or better known as tidal coupling. This phenomena is that in which one body is gravitationally bound to another so firmly that one face always points to the principal body, just as it happens to the Moon, which always has the same face pointing to the Earth. This means that it will always be daytime in one hemisphere of the planet, while in the other there will be a perpetual night. In this case, the environmental conditions of the planet will depend to a large extent on the magnitude of the atmosphere it possesses, if it has one at all. Also of its composition and the amount of water on its surface. If Proxima B has physical characteristics similar to those of the Earth, we could be facing what is called an eyeball planet. In this case, if the volume of surface water were limited, the hemisphere facing the star would be desert, while the night atmosphere would have an accumulation of frozen water. In such circumstances, areas of perpetual twilight could enjoy optimal environmental conditions for life as we know it. If the amount of water were considerable, on the order of 60% that of the Earth or more, if the atmosphere exerted a surface pressure of the order of 1 bar, and if nitrogen were the primary constituent, we could be facing an ocean world, completely frozen except in the region facing its star. In a previous video, we discussed the ocean planets in much more detail. We invite you to watch them. Proxima B, an ocean planet? If Proxima B is an ocean planet, we could face a planet completely covered with liquid water, with the same range of surface pressures, the same amount of water, and an atmosphere dominated by CO2. But on the other hand, with a more massive CO2 atmosphere, there would have been a runaway greenhouse effect. So the exoplanet would be an exo-Venus, that is, a world as unhospitable to life as Venus, our false twin in the solar system, which, despite being very similar in size to Earth and being the closest, is the least suitable for life as we know it due to its hellish temperatures. Scientists have speculated that if Proxima B had an atmosphere, it could have a temperature of 30 degrees Celsius or 86 degrees Fahrenheit. Still, even if it did not have an atmosphere like Earth, it would have a temperature of minus 40 degrees Celsius or minus 104 degrees Fahrenheit. In both cases, the temperatures are not so extreme, and it would be possible that living things could develop in those conditions. Whether it is an ocean planet or an eyeball planet, despite all the favorable conditions that Proxima B holds, scientists observe something that could destroy any hope of finding life on the planet. Life-destroying solar flares. During the analyses of the star Proxima Centauri, astrophysicists discovered that this star expels from time to time vast eruptions of plasma and radiation that would sweep away any atmosphere that Proxima B had. In addition, these eruptions would not only sweep away the entire atmosphere, but would exterminate any traces of life. Some astronomers think Proxima B could withstand these radiation eruptions if its atmosphere is thick enough or has a magnetic field like our planet. On Earth, the magnetic field produced by the movement of the planet's core protects us from the dangerous and harmful radiation of the Sun. If Proxima B has a magnetic field similar to ours, it could have a second condition that helps it to have living beings. Unfortunately, with current technology, it's difficult, if not impossible, to define if Proxima B has a magnetic field like the Earth. The only way to find out will be when the European Extremely Large Telescope comes into operation, which will be the largest optical telescope in history. We've also already made a video about this telescope. we recommend you check it out. All these are nothing more than conjectures based on models that may be more or less adequate. We are facing an exoplanet of terrestrial mass, located in the ideal area so that it can host life. Yes, a potentially habitable world, but this does not mean that it is. In any case, the term habitable must be taken here in its broadest sense. Perhaps a better definition for this type of exoplanet could be a world with extreme environmental conditions, uninhabitable for us, but not for certain types of microorganisms, for example. What do you think? Do you think Proxima B could have the necessary conditions to house living beings? Let us know your opinion in the comments of this video.